Hello, now we'll solve example 1. So consider a hydraulic jack being used in a car repair shop as shown in the figure. So the pistons have an area of A1 equal to 0.8 centimeter square and A2 0.04 meter square. So A1 is smaller than A2. Hydraulic oil with a specific gravity of 0.87 is pumped in as the small piston on the left side is pushed up and down, slowly raising the larger piston on the right side. So a force F1 is applied on the smaller area to create a force F2 on the larger area. A car that weighs 13,000 Newton is to be jacked up. So the density of water here is 1,000. At the beginning, when both pistons are at the same level, H equal to 0, so the two pistons have the same level, calculate the force F1 in newtons required to hold the weight of the car. So first, we need to choose 2 points that lies on the same level in the hydraulic oil. So as we said before, if we have the same level in the fluid, we should have the same pressure. So P1 is equal to P2, and the pressure is the force over area. So P1 is F1 over A1 equal to F2 over A2. So we will have F1 equal to A1 over A2 into F2. Now we replace the numerical data. F1 is equal to 0.8 times 10 to power minus 4 to convert from centimeter square to meter square over 0.04 into 13,000, the weight of the car. So F1, the force required to hold this position, is 26 Newton. For part B, repeat the calculation after the car has been lifted 2 meters. So now the new position, we'll draw the new position. So for the larger piston, it will be displaced 2 meters above the small piston. So we'll draw the new position. So here piston 2 should be above the level of piston 1 with the difference in level equal to 2 meters. So H equal to 2 meters. Here the force F1 exerted on the smaller piston and force F2 exerted on the larger area piston. So we take 2 points at the same level, point 1, and let's call point 2 1 prime, and above the point 1 prime we have point 2. So the pressure at point 1 is equal to the pressure at point 1 prime, since they are at the same level. And if we apply the hydrostatic formula between 1 prime and 2, we'll have P2 minus P1 prime is equal to minus gamma oil into Z2 minus Z1 prime. So minus gamma oil, Z2 minus Z1 prime is equal to H. So we'll have P1 prime in this case equal to P2 plus gamma oil into H, and P1 prime is equal to P1, so we can say it is also equal to P1. So we will obtain P1 equal to P2 plus gamma oil into H. So P2 is F2 over A2 plus gamma oil into H, and if we multiply both sides by A1, so P1 into A1 is just F1 equal A1 over A2 F2 plus gamma oil into H into A1. So to calculate gamma oil, we can use the specific gravity given for oil. So it is the specific gravity into gamma water. So gamma oil is equal, the specific gravity is equal to 0.87 into gamma water, raw water times G, so 1000 into 9.81. So gamma oil is equal to 8,534.7 Newton per meter cube. So in this case, F1, we replace the numerical values. A1 0.8 times 10 to power minus 4 over A2 0.04 into F2 13,000 plus gamma oil 8,534.7 into H 2 meters into A1 0.8 times 10 to power minus 4. So F1 will be equal to 27.4 Newton. So after the car has been raised 2 meters, the required force to hold it in this position will be equal to 27.4 Newton. And as you can see, it is larger than the force required in part 1.